Rồi, 3, 2, 1. Hello teacher. Today our group will present about our final report of the topic of forecasting customer retention rate. And this is my team, which contain three members is Bảo Châu, Hoàng Hà is me, and Đào Gia Hải is the leader. The agenda of our presentation have 8 features, and let's take a look at our project summary first. The targets we have to is provide digital transformation solutions for e-commerce business. Also bringing new technology into e-commerce activities and learn and research new technologies in digital forecasting field. About the methods we use, here we have the environment is Python and its libraries. The machine learning models have been applied with three features of logistic regression, XGBoost, and light GBM. We also use a deep learning model, LSTM, which stands for long short-term memory. About the data visualization part, we're using Streamlit and Pandas libraries. The outputs we want to show you is the visualization of the result, improving overall forecasting accuracy, upper and lower confidence intervals, and provide business competitive advantage. Let's take a look at the topic overview. Today's world requires agile strategies and management. This is where business forecasting can help, enabling businesses to plan for unexpected events. Business forecasting involves forecasting tools and techniques to help businesses predict certain developments, which will provide organizations with beneficial information for their decision making. The reasons why we choose the topic is offers a compelling intersection between business impact, machine learning techniques, and the opportunity to develop valuable skills. The customer retention is a well-suited problem for machine learning techniques, and the customer-related data is often readily available for businesses. There are many importance of choosing this topic. First is aim to grow sustainably over the long term for development of any business. The customer retention directly affects a company's financial performance. Acquiring new customers can be expensive, while retaining existing customers is more cost effectiveness. The high customer churn rates can lead to market share loss and reduce brand loyalty. Now we come to the overview of forecasting customer retention rate. We will begin with the definition of customer retention rate. Customer retention rate refers to the percentage of customers who continue to do businesses with a company over a given period of time. A high customer retention rate indicates strong customer loyalty and satisfaction. A low customer retention rate may indicate issues such as poor customer experience, inadequate product or service quality, or strong competition. The meaning of customer retention rate is really important in an e-commerce business context. It first improves forecasting accuracy, better resource allocation. Third, it reduces marketing costs, also increase sales and expanding the business market share. And we have the applications of customer retention rate forecasting in research and in real-world context. For the research applications, it will provide empirical studies, methodology development, and longitudinal studies. The practical applications will have strategy formulation, marketing and communication, affect the CRM, which is customer relationship management, and the performance checking. Now we come to the dataset information of our group. We choose the dataset from WSDM KKBox Joint Production Challenge. KKBox offers a subscription-based music streaming service. The majority of KKBox subscription length is 30 days. A lot of users resubscribe every month. The key field to determine retention are transaction date, member expiration date, and is cancel. The criteria of retain is no new valid service subscription within 30 days after the current membership expires. About our tables we use here, we have 4 tables in total. And the first is member V3 .csv, which has 6 columns and nearly 7 million rows. And it has some features of MSNO, city, birthday, gender, registrifier, and registration anytime. The second table is the lắc
Đây này, đây này.
Tự thật. 1, 2, 3. The second table is chain v2.csv, which has 2 columns and nearly 1 million rows. The first column is MSNO with the user ID, and the second column is churn. Churn is defined as whether the user did not continue the subscription within 30 days of expiration. If churn equals to 1 means churn, and the opposite is churn equal to 0 means renewal. The third is transactions v2 CSV with 9 columns and 1,431,009 rows, which have the MSNO payment method ID, payment play days, plan list price, actual amount paid, is auto-renew, transaction date, membership expire date, and is cancelled is the column we will focus on. And the last table is user logs v2.csv with 9 columns and nearly 20 million rows. And we have some features here also. MSNO date num25 the songs play less than 25% of the song length, and also has the definition for the num30, num75, num8, num9, a5, num100. We have the num UNQ is the unique songs played, and total sex is total seconds played. And next is the overall process, and this part will be presented by Hai.
So, hello, my name is Hai, and I will represent my team to talk about the overall process and data exploration and feature engineering. As we all know, the overall process will always begin with the exploration of the dataset, and after that we will do the feature extraction to add more feature or to do some or to drop some columns, and after 2 of them we going to train the model. In the training process we will adjust the parameters to get a higher score, and after training and adjusting the parameters we will have the finalized model, and we will apply this model to the test dataset to get the predicted labels. So let's move to talk about some demonstration and data visualization about the exploratory data analysis. The first one is the age group. This plot is about the customer age group. From this we can see the most of the customer are lower. The customer age are lower than 69, and this insight will be very helpful if we are doing marketing or sales, but we are doing machine learning. And from this we can see that higher than 69 is the outliner, and we will going to remove the outliners and impute them later in the pre-processing function. The second one is the actual amount paid. Is also the same with the previous one, and we can see that there is a lot of outliners out here, and we are going to do the same thing to remove the outliners and impute them. And the third one is the is cancel. And we can see that if the customer is changed, they are more likely if the customer retained with the business, they are more likely to not cancel the subscription. But if the customer is changed, they are likely to cancel the subscription. This is also important features to that can have a great impact on the model in the training phase. And is auto renew count plot is also the same with the previous one. If the customer is changed, they are likely to not trigger the auto renewed. But if the customer is not changed, they tend to keep the auto renewed. And for the last one is the plot about the song of song that the customer played. For example, if num 25 is the total length of the song that the customer played, and the same with the 50, 75, 985, 100, and unique is the total of unique song that the customer played. And from this we can see that there is a lot of outliner out here, and we can see also we can see that the dataset is not centralized, it is distributed. So we have a lot of errors and we have to impute them with the appropriate values. And after some demonstration, we will go into the function to pre-processing the data. In this function, we are going to remove the outliners, impute the missing data, and convert the datetime time for the datetime columns. For example, with the payment method ID, why we impute with the value that is 0, because there is the first reason is there is no value 0 in these columns, and the second is payment method ID is a category variable, so a 0 may be better to represent the missing value. And the second example is for the data num25 to check where they have the aligners, we print out the percentage of the value in the columns, and 90% of the column the value is lower than 15, so above 90 we can assume that there are a lot of outliners, so we are going to replace them with the NaN values and impute them with the median value, which is 2. After reprocessing, we will do the feature engineering, and this function we will add new columns, drop some columns, and one hot encoding for the transaction year, transaction month, and transaction days. And after that, we will train the model. So before train the model, let's talk about the model theory.
The first model we talk about is logistic regression. So the definition is it is a statistical model, and it's often used for classification and predictive analytics. The outcome is a probability, and the dependent variable is bounded between 0 and 1. For binary classification, a probability less than 50% will be routed to 0, while a probability greater than 50% will be routed to 1. And the logistic regression fit an essay logistic function. For example, if your car hasn't been in service for years and now you want to predict if it is going to be broken down in the future, then the curve will go from 0 to 1, and that means the curve tells the probability that a car is broken down based on its years in last service. The threshold values greater than 50% means the car will break down. Here, the threshold value is 50% indicates that the car is more likely to break down after 3 years of uses. And with the probability less than 50%, the value will be rounded up to zero and the car will not break down. The next model is XGBoost. So XGBoost stands for Extreme Gradient Boosting. It's a scalable distributed gradient boosted decision tree machine learning library. It provides parallel tree boosting and is a leading machine learning library for regression, classification, and ranking problems. So, XGBoost is gradient boosting, but with some performance enhancement. Usually, we have a dataset in a table format where the rows are data sample and the columns are features. This takes too much space, so XGBoost stores data in a compressed per column format instead. If we have a lot of data, which is usually the case, then we divide data into blocks. These blocks can run on separate machines for parallel compute. XGBoost operates quick on sorted column with this compressed smart column format. We can sort every column in every block by value. And to optimize even further, decision tree nodes are constructed in a breadth-first fashion also in parallel. On the optimization together make XGBoost up to 10 times faster than normal gradient boosting. And because of this, you can see XGBoost everywhere from product recommender system to have price prediction system and to fraud prediction. And next is LightGBM. LightGBM is a gradient boosting framework based on decision tree to increase the efficiency of model and reduce the memory usage. It used two novel techniques. The first is gradient based on one sampling loss, and the second is exclusive feature bundling (EFB). Uh, First is cost. In gradient boosted decision tree, the data instances have no native weight, which is leveraged by cost. The data instances with larger gradient contribute more towards information gain. And with exclusive feature bundling, uh, EFB is a near lossless method to reduce the number of effective features, just like one hot encoded feature. In the sparse space, many features rarely take non-zero value simultaneously. And with deep learning, we have long short-term memory. So long short-term memory is a type of recurrent network. And to be more clear, recurrent networks work in the sense that they have a node and this node receives some input. That input is then processed in some way like we have some computation. And what makes RNN nodes a little bit different is the fact that it is recurrent and that means it looks and this allow us to remember the previous step. But over time, as more and more information piles up, RNN node become less effective at learning new things, so the LSTM will provide a solution to this long-term dependency problem. And that is to add something called internal state to RNN node. And it is actually a LSTM cell. We have the LSTM cell consists of 3 gates. The forget gate will decide what information needs attention and what can be ignored. The input gate says that what new information should be added or updated to the cell state, and the output gate decides what information can come through the output gate. And these gates can be assigned number between 0 and 1. The 0 means the gate effectively closed and nothing gets through, and 1 is the gate wide open and everything can get through.
Hello, it's me again. So let's move to the last report, which is the result, the dashboard and the future work. This is the first model, which is the logistic regression. The model performance before the feature engineering was, for the last one, was pretty low, but this final report, after we do the feature engineering, the base performance for this model was improved, and for each model we have done more twice attempt for each, and this is the first attempt for the logistic with the C value is equal to 0.1, and you can see the improvement here. And for the second attempt we change the C value to 0.01, and with this second attempt the accuracy for class 0 is still the same, but the last one was a little bit higher, and this is also the best performance for this model. And we also try with some other params, but this is the best result that we can get. So I think if we want to get the other result or the better performance, I think we have to do more in the future engineering step. So this is some one of our work in the future. For the second model is the edge boost the model performance before the feature engineering for is acceptable for both class, and for class 0 is high, but last one is just acceptable. And so in this final project, after we feature engineering, the performance for both class have been improved for the base param of this model, which is the random state, the n estimators, and the learning rate. And in the third attempt, we add some new params, but the total accuracy of class 1 is still the same, of class 0 is still the same, but the class 1 was decreased 2%. And in the fourth, with the same param, but we change the learning rate from the previous, which is 0.01 to 0.1, and the accuracy for the model is improved, and which is also the best performance for this model. And to our only deep learning model, which is the LSTM, long short-term memory, we also done to attempt for this model, and this is the code for this model. We reshape the input, we define, we plot the history while training, and we evaluate. This is some this is the history while training the model, and this is the accuracy of the model. In the second attempt, we define another way the model, but the accuracy is still the same. And I think it's like the logistic. If we want to improve, we have to do the feature engineering again, and improve the feature engineering step to get a better result. And for the final is the light GPM. And for this model, we have done a lot of attempts. So it's nearly about 5 or 6. So this is the first attempt with the base parameter, and the final is and the performance is pretty high. And the second attempt we changed the num list from 30 to 50, and the score for the class 1 is just 1% up. And we keep updating the params, the value of the params, and the score still updating. And in this we still do the same. And for this attempt we add some new feature, and the score for the performance for this model is pretty good. For both class 1 and class 0, but in this model we noticed that the model was overfitting. So why we know that? Because when we get the score of this model, we do the testing phase, but the result is not high as we expected. So I think this model just overfitting the dataset. And for the last attempt for this model, this will also give us the best result for the test on the cargo, but we have to adding the params for this model, and the best performance, not the best evaluation, but is the best output for our light GPM model on cargo test. So that's all about the model performance. We move to the model performance comparisons. And like I said before, the light GPM fits the model performance is on pretty high for each attempt. So this is nearly or is higher than the XGBoost, and the LSTM is always the lowest for the precisions and recall, and also the F1 score. And this is the output result on the cargo. Like I said, in the model performance, the light GPMs give us the best submission on this challenge, and it brings us to the top 180 on this leaderboard. So that's all about the model performance and the result. Let's move to take a look at the dashboard. Like a previous report, we using Streamlit, and in this final report we updating the code. This is just some lines of code of our dashboard, and this is just a screen of our dashboard. Let's see some another. So this is the confusion matrix that we applied for each model. This is the true values and the predicted values. This chart is for the comparison about the E and the E predicted from the model, and below it is the model evaluation with the RFNE, the MAE, and the R2. This is a dataset profile report to do the detailed exploring, and while after doing it, we noticed that we have to do more in the futures, and so this for further development for this project. The first one is using the entire dataset, because in this case study we just use the version 2, because the version 1 is too big that our computational resources does not have enough, so we just use the version 2. So in the future we will use the entire dataset for more accurate and robust result. The second is trying stacking the model. We will combine the prediction from multiple models and leveraging each model strength to improve the accuracy. The third one is exploring the featureization. We will invest more in the featureization to get the better result. And the fourth, so the final one is we can do away in the data processing, and we do the upsampling to see what if the upsampling does the effect on our trained model, because the class imbalance and enhance, and it also enhance the model. Here's the references. This work assignment, and thank you. So let's move to the code demo and the dashboard demo for this final report. So this is our full code for this project. Nearly 2 months ago, we used two file names, the uptemp1 and the EDA pre-processing. To do the uptemp1, we do the EDA pre-processing the data, and we also report this file into time report, and in the final report we also mention this file. So for the importing the data for the first, we have to importing the dataset. We import the train, the members, the user logs, and to explore the dataset, we merge the train, the members, the train, the user logs. So for the train and members, we pass the detail about the dataset to see the value inside, to check out the outliners and the known values. The plot for the city distribution, the register via distribution, the birthday, and here you can see that on the slide we have a plot demonstration for the birthday, and this is the function that we group the age from this to from 0 to 9 and to 60 and 69. And as I mentioned before, the age which that higher than 69 is the outliner, so we will replace the outliner with NaN values, and we just drop them, and so we impute the medium value for this known values for the age group. And for the register in time, we also do this is the code for get the median value for, and in the train and transaction we also import and merge. This is the plot for all the columns. This is the column. Like I said before in the slide, there is no zero value in this payment methodology, so we impute them with the value zeros, and this is a category variable, so a zero value may be a better fit for the missing value. The payment plan days, the plan despite the actual amount paid. This the auto renewal is cancelled. So this is the function to print out the percentage of each value in the columns or in a feature. And with this function to print out, we can check that the outliners start from where, and also we from that we can remove them and impute them with the appropriate values. We're getting the median value for the plan display and the actual amount paid. Train user logs. For train user log, we have a function to backlog on the column, and we can see that there is a lot of outliners. There are a lot of outliners that we mentioned. We also print the percentage. We can check the median value for each. So here is the preprocessing function. We merge all them, and this is the dataset information. This is the count of known value for each. This is the function for preprocessing the data. In this we fill NaN. We convert the gender to female, male with the value 1 and 0, and then the known value in gender we fill with the 0 value, and always and the same with on iReport on the slide. Here we check out the outliners range. We remove them and impute them with the median value of each column, and the function return a new data set. So we can check here. This is the new data set, and after that, after reprocessing the known values, and we export here, and we also do the same with the test data set. And for the previous report, nearly 2 months ago, we used the attempt 1, and in this attempt we don't do the feature engineering, so the base model for the performance was not high. And this is the base model performance for the logistic and the XGBoost. We also do the upsampling by smoked, but the result is not acceptable. But the result is still the same. So for the second, after that we do the attempt too. In this attempt, we also do the feature engineering. We bring out the correlation matrix to see the coherence of each column. We drop those columns. We add new columns. We convert date. We add a tenor column. So that we also the one hot encoder for the transaction year, the transaction month, and transaction date. And after doing it, our dataset has 68 columns. And now the dataset is pretty large. So this is the logistic. This is just the logistic test performance. So this is the submission for the dataset. We also do the same with the test dataset to add the feature engineering, and we print out it here. This. So after doing the pre-processing and feature engineering, we will go to our model. So the first one is the logistic. We import the libraries, we import the data, we convert to some registration init time and experience date to string time for the model. We split the dataset, and we do the training section. So this is the code for the best result of the model with some params. And after we train the model, we will import the big code to save the model. And this is the function to save the model, and this is the model folder. In this folder we have the variant of each model. For the LGP we have 6, LSTM we have 2, the logistic we just have 1 because we override the file, and the XGBoost we have 4. This is the function to bring out the submission for the submission on the cargo. And for this logistic we also do with 2 or 3 parameters, but the result is not good, so we don't report it in the slide, and we just collect 2 of them, which is the first one and the last one for this. So move next to the next model, which is the XGBoost. Same step with the logistic. And in this model we have 4 variants of each model that we save here, and the best performance for this model is this with this parameter. And we also print out the valuation matrix. We also import the pickle to save the model, and this is the second attempt for the model, or the second code. We also do the same for each model, nearly the same step, but it just changed in the model defined and model training. We also use the function, use the code to bring out the submission. And here is the important features for each model. So move next to the deep learning model. This is the same with two previous, but it has some change here. For this LSTM, we have to reset the input to be 3D, and we have to define the model. This is the first time we do with the epoch is equal to 50, and the accuracy is 0.897. And for the second time, we do the epoch 5, and the accuracy is still the same. For the third attempt, we define again the model, and the accuracy is still the same. So we think if we want to improve the dataset, we have to do the feature engineering again. And so save the model and print out the submission file. So print out the important features. And this is the light GPM model file. Same with the logistic and the attributes. This is the model we define here. For this, we have this is the best performance, not the best valuation model while training, but it gives us the best output on the Kaggle test for this model. This is the test for the output valuation. You also the same file, and we also print out the important feature. This is the important feature for this model. So let's check out some other folder. So this is the important folder. In this, it includes the important features of each model. Okay, these are the features in the percentage. This is the data that we improved, what we do. So that's all about the code. So we move to the dashboard. So let's open the app. We use PyCharm. And in order to the code work as expected, we have to move this to be outside, because it will conflict with the path to this file in this Streamlit code. So to run this app, we do the command so yes, it's done here. So this is the output valuation from Kaggle. This is the log function, and the log function indicates that the model predicted probabilities are close to 0 is very close to the true labels, and on the other hand, a log loss value close to 1 indicates a poor performance, where the predicted probabilities are far from the true labels. And this is our submission on the Kaggle comparison, and the best performance is the light GPMs with 0 and 1439. And the best performance for this comparison, and also the research paper, is from Brian Gallery for the score of 0 and 0.079, and it is come from the XGBoost for this. And after the output valuation from the Kaggle is the model comparison. With the interactive dashboard, we can choose which metric we want to see, and if we want to see the precision score, we can choose it, and it will calculate. So this is the model comparison for the precision. It takes a long time because the dataset is pretty large, and so it takes a lot of time to calculate the metric. So if we want to see, we can choose, and when we hover on each bar, we can see the precision for each model. For the SG push is 0.93, plastic is 0.86. We can also zoom out. We can also move the table for interactive, so we can zoom in or zoom out the table. So after the comparison, we will go to the detailed model performance, and we also display the best performance for each model. This is the classification report, the confusion matrix, and the comparison between true values and predicted values for each model. This is the classification report, the best performance for the XGBoost model. This is the confusion matrix. To read it, we have to take a cross for the true label 0. We have look from the bottom for the true label values, and this is the true label but predicted label 0, and this is the true label 0 but predicted label 1. Cái này là this is the negative, này là true true, cái này là true false, which is này also là true false, cái này là true true. So after that, we have the comparison between the true values and the predicted values from the model. You can see that this is the predicted value. It count about 15 millions, but the true values was a little bit lower. So this is the model evaluation, the RMSE, the MAE, and the R2 of each model. For the same with the logistic, the line GPM, and the classification report, and the confusion matrix, and model evaluation for the model LSTM. And for this LSTM model, the score for the last one was 0, so we have a future work for this on further development. And after that, we have the important feature list. This is the important feature list from the light GPM because it gives us the best result on the Kaggle. And the important feature is the membership expire date, and this is just the first step. Tap on the interactive dashboard, and we have 3 task but this is the same. This is just for the, we just demonstrate one tab, and this is the same for the 2 left. And for this we will exploring the dataset. We will have a detailed for each dataset in this dashboard. And when we click on the generate raw file report, it will the code will do the generate raw file report for us. This is the user raw file report. This is the tab, the load model, calculating the performance of each model. So when we click on the generate raw file report, it will calculate
and bring out the raw file report for us.
So it's here. This is the overview of the dataset. It gives us the information about each column. The instrument, the city, the birthday, the genders, the register via the registration in it time, and to see, for example, for the birthday, if you want to see the detailed, you can see the median value is the range, the maximum is, you want to see in histogram the common values. Value 0 is the most common for the birthday. The extreme values. This gives us this is the detailed exploration about the dataset, and it helps us a lot in the data reprocessing step. And it is also the same with the transaction data and trend logs data. So this is all about the interactive dashboard. So let's move to the Kaggle output valuation from Kaggle. So let's open the browser. This is the leaderboard. This is the comparison to predict the change. And this is on the attempt we have tried, and the best performance is the light GPM. And this is the leaderboard. And first top one is Brian Ray Glory with the model XG Boost, and he mentioned that the key to achieve this score is about the feature engineering. Yeah, so the public. So that's all about our final report. If you have any questions, just feel free to contact us. Thank you for your listening.